Welcome to the lecture 4 of this Python programming course. Today we'll talk about memory management in Python. We'll discuss some basics, and in the upcoming lectures we'll delve deeper into this topic. So let's get started. So we already talked about variables in our previous lecture. We talked about how we create variables and how the variables differentiate between the objects. We talked about the major difference between a variable and an object. So when I create a is equal to 10, this 10 is nothing but an object. This a is nothing but a name. So inside the stack, the name is created. The name is called a, and inside the heap the object is created. The object is nothing but the 10, and we try to link. Okay, we link this name to this object. How we link this name to the object? For example, if this object has an address 1000, then we will put this 1000 here, so that the name gets linked to the object. So this is how a variable is created. We don't need to specify the data type in Python. During the runtime it will automatically you know get assigned to this object. The type, we all know that you know an object is nothing but, it's like a child class of this Py object. So for every object there will be a Py object like this, where we have the value, we have the type, and we have the reference count. We'll talk more about the reference counts in a bit. So the value is nothing but 10, the type is nothing but int, and the reference count is 1, because one name is referencing to this object. So for this object we have only one reference count. If we have two, then this one will get incremented to 2. So based on the references, based on the names pointing to an object, we will update this reference count. We will talk about it in a bit. So as of now we only have one name, so the reference count is 1. So when we create an object, and during the runtime, our runtime is nothing but when we open the application, when we click on the application, the operating system will fetch the application from the secondary memory to the RAM, and inside the RAM the instruction will get executed one by one. So during the runtime the Python will check this object here. So after checking this object, it will decide what type is it. So it already has some, for integer it has class int, and inside this class it has so many values that are acceptable. Okay, so when I give the value 10, the Python will already know that the value of the data type of this value is nothing but integer, so it will directly assign that type to this object. Okay, so that's the basic idea of variables. In Python the variables are a bit different from the C programming variables. In C type variable, what happens is that when I create a variable, we need to specify the data type. Okay, in C type we need to specify the data type before the compilation. So the reason we need to specify before the compilation is because we need to tell the compiler what data are we assigning to this A. Okay, but in Python the Python virtual machine will decide what type we assigned. So here we need to tell the type. In Python we don't need to tell the type, the Python will automatically assign the type. That's the basic difference between the variables. And another difference is that in C language, whenever I create a variable like this integer array, what in the memory what happens is that this variable, we have two variables. I'm trying to create two variables here. We have A and we have B, and the variable is present in this particular location. Let's assume let's take the address in the hexadecimal, 45A1. This is at 77A1, and the value here. Okay, the value is 5, the value of b is 5. So this is how the the variables are stored in C language. For variable there is a location, inside that location the value is present. So when I try to change the value here, int a is equal to 6, what happens is that the value will get replaced. This 5 will get replaced with 6. Okay, so at the particular location the value will be replaced. Okay, we are not creating anything, we are not deleting anything. There will be a value present at a particular location, and when we try to change the value of the a variable, the previous value will get replaced with the current value. So here the previous value is 5 and the current value is 6. Here it will automatically get replaced. So this is it's a bit different from Python. We all know that in Python we don't have concept of variables, we have the concept of objects and names. So the name is created in the stack and this name is pointed to an object here. So this is in the stack and this is in the heap. So when we create this object, it will get created in the heap, and the address of this object, this which could be anything. Let's take 1000 here, and the 1000 is stored in the location of the A. So at A the address of the object is being stored, but here the value is directly stored at the location. So this is the C type, and this is Python. So this is the basic difference between the Python variable and C-type variable. We can assume the C-type variable as a fixed bucket. Okay, if you have a bucket like this, we are gonna store the variables into this bucket. Okay, we can assume it like this, like a bucket where we store the values inside that bucket. So, but in Python, it's different. We know that Python has names, not variables. So we have an object like this, and we have a name. We'll store like this. For example, let's take another name like this. Movie is equal to anything. Let's take, Captain America. So this movie is the name. This Captain America is a string object. Okay, this is a string object. So what happens in the memory now? We will have stack. Sorry, we'll have we will have the stack and we'll have the heap. So inside the stack, the name will be created here. The movie, the name is nothing but the movie here. That's what we created, and the object is created in the heap. The object is nothing but the string object. Okay, this is the string object. So how the py object is created for this particular object here? So this is the py object. Inside the py object we have value. What is the value? Value is nothing but Captain America, and we have the type. What is the type of this object? It's string. And what is the reference count here? We have only one name pointing to this object, so we have only one name pointing to this object, so which is the reason we updated the reference count from 0 to 1. First initially it will be 0, so whenever we will assign the movie to this, I mean any name to this object, it will update it to 1. If we assign more than more reference variable, then the reference count will be updated. We'll talk about this in a bit. So we have different types of objects in Python. The first one is simple and nothing but the fundamental data types that we discussed in our last lecture. So which is nothing but int, bool, float. We have another data type, container. Container objects are list, set, tuple. We have dictionary. We'll talk about all these data types in our next lecture. As of now, we'll just try to understand what is meant by list. So a container object is nothing but it stores a group of objects in it. Okay, if we whenever I try to create a list object, what happens is that we will group some objects here. If I want to group 10, 20, 30, 40, 10 is nothing but object 1, this is object 2, this is object 3, this is object 4. So we have four objects here. We are trying to group these four objects, and we are using one single name to, you know, represent this object. So inside the stack we'll have list, and inside the heap this object, the list object is created here. This is nothing but the list object, and this will get pointed to this. Okay, this is nothing but the container object. It's simple, is nothing but what we just defined before in our previous slide. A is equal to 10. This is simple because it is integer data type. Bool could be a is equal to true or a is equal to false, and for float we can assign anything with a point. Okay, so these are called the simple, and these are called the container data types. Container are nothing but when we want to group so many objects, we use the container objects. Okay, list, set, tuple, dictionary. um, so so when I So when I assign any object to a variable, what happens behind the scenes, that we need to understand here. So how the Python will understand what's going on? I mean, how Python will know that this is variable? How Python will know that an object is created? We look at how variables are created here. So we all know that, Python is a dynamically typed programming language, which means that during the runtime, the Python will automatically detect the, data type of an object. Mm, if I take movie is equal to captain, then the Python will know that. mm, then the Python will. mm, okay. Okay. So when I create a variable movie, the Python already knows that if it's a sequence of character, then it which means it is a string. So Python will automatically assign the string data type to this object. Okay, we don't need to explicitly specify it. We already discussed it before. So in Python, types are determined automatically at runtime, not in response to the declarations in your code. Okay, we don't declare the data type inside the code based on the object. I mean, based on the type of object we give to the Python virtual machine, it will automatically assign the data type for that particular data inside the object. Okay, so when I create a variable like this, when I create a variable a is equal to 3, so what happens here? First we need to create an object to represent the value 3. So first we'll create an object like this, 3. Then we'll create a variable a. If it does not yet exist, we'll talk about this point after a moment. But the only point we need to understand is that first, whenever we are trying to create a variable or any object, first the Python will check if the object or the variable already exists in the memory. So if we are creating a is equal to 3, first it will check if the a exists in the memory or not. Then it will check if 3 is exist in the memory or not. Then it will create. Okay, we will talk about this in a bit. So then it will create the variable a, and then it will link the variable a to the new object 3. So this is how an object and the variables are created. So we can also understand it with some creation. So first point is that how the variable is created. Okay, first variable creation. So a variable is created when we assign a value to it. So now the variable is created, a is equal to 10. Then next, the type, okay, the type of the variable. So based on the value provided here, okay. So the type of the variable. So we need to understand here is that the type is not associated to the variable. Okay, the variable doesn't have any type. The variable doesn't have any type. It is just a name. The type is always associated with an object. Type and object are related, but variable and type are not at all related because variable is nothing but a name. And next, usage. When we will use this, first we'll create like this, and the type will be assigned to this object because variable has no relation to the type. Then how we are going to use this variable, usage of this variable. So the variable is used when we encounter that variable in the code. When we encounter the variable in the code, the value is assigned from the memory to that expression. So here I created a variable here. Let's So here I created a variable, then the type is assigned to the object, and then where we are going to use this variable. So if I am going to print a, then this 10 will get replaced here, and then the output, the 10 will be outputted to the window. So this is what exactly happens in the memory. First the variable is created, then the type is assigned to the object, then we'll use the object. I mean, whenever we encounter the variable inside the code, then the value of that variable will be assigned to this variable. Okay, so we can understand this these 3 points are the conclusions here. So the variables are entries in a system table with spaces for links to the object. As I said, variables are entries inside the stack. These variables are nothing but entries. Okay, these are nothing but the entries with spaces for links to the object. We have every variable has a space, and this spaces we are going to assign to the objects here. Okay, this is the heap. We are going to assign each and every name to this object. Okay, so this is the point, and then objects are pieces of allocated memory with enough space to represent the values for which they stand. What are the object? They are nothing but the pieces of memory locations. They are nothing but the pieces of memory locations, and the references are automatically followed pointers. These are the references because I'll draw it again. These are the references. What are these? These are references. References are pointing from the variables to the objects. These are the references. So that's all about the variables. I hope you understood the the basic idea and what exactly happens when we create a variable. So we already discussed this. Type always live with the objects, not variables. Let's try to understand this one first. Field coded, because this is very important. You know, before a few minutes ago, I talked about py object. For every object, three values will be created here: value, type, and reference count. I told you that we are going to discuss reference counts in a bit, so this is the right time to talk about the reference count. So first of all, what is meant by a reference count? So when we create a variable, an object is created and a variable is created. So variable is nothing but a name, we know that. So 10 a. So what is meant by the reference count? So the reference count is nothing but the number of references that this object contain. So we can also say that the number of names that the object contains. So here we have only one name or one reference. So the reference count is one. What if we have two? Then the reference count will be two. What if we have three? Then the reference count will be three. Here, I mean, these two will be replaced, and 3 type, we all know that based on the value the type will be assigned. So here what I'm going to discuss is that we are going to discuss an important topic here. So we will try to understand how the variables work. First we will code this one and keep yeah so first of all, I'll create, I hope you can see this one. Let me zoom it. Yeah. So first of all, I'm going to create a string object here, spam. You can take anything. Okay, let's take a name here. A is equal to Vikas, and next I'm going to declare the same variable here. So please observe this carefully. With the same name, what I'm going to do is that I am going to create a different value. Let's take it. Let's take an integer here, 1900. So what we discussed a few minutes ago, like in the C, what happens when I try to change the value? When I try to change the previous value will get replaced with the current value. Let me go to that slide and explain you again about it. So what's going on here? What's happening here? So here we have a variable here, and we have a location for that variable. I mean that the variable is located in that location. So when I try to where is my pen? Yeah. So first, why couldn't I rub this one? So first we have 5 here, a is equal to 5. So when I try to change it, this value will get replaced with 6. But the location is the same. Okay, we need to understand here in C language, the location is same. The location is not being changed. So let's see what happens in Python when we try to change, I mean when we try to replace the value of a particular variable. So first of all, here because an object is created and this a is assigned to that object, and then I'm going to change it. First let's try to print id here, id of a. So this is the address of this a. Now now I changed it to the integer object. So here print id of a. We all know that id is nothing but a function which will return the address of a particular object. So this is a here will print. So if you can see that the address is being changed here, but in C language the address is same, but here the address is changed. So what exactly is happening here? We will we'll see that now. Yeah. So when I write this one, when I execute this particular line, then this is what happens inside the memory. And then I'm trying to change the value of this a. So what happens is that first the object is created. I already told you that whenever like a variable is created, first it will check if the object exists in the memory or not. Then it will check if the variable is present in the memory or not. First it will check if the object is present in the memory. Next it will check if the variable is present in the memory. So the pvm will, you know, will do these two things. First it will check if the object is present in the memory, and then it will check if the variable is present in the memory. So here it will check if the a is present in the memory or not. We already know that we already created a before, so the a is already present in the memory, so it's not going to create it. Then it will check if the spam exists in the memory. No, it's not, so it will create it. Spam. So what it will do is that it will delete this reference count. So I'm also going to do here, okay. For this a, first when I create this one, the reference count is 1. Please observe this carefully. So when I try to, this is 47 object, okay, this is 47 object. And when this object is created, the spam object is created here. This is a spam object. And for this one, the type is string. And the value is spam. And the reference count is, now this will get removed and it will point to this. So the reference count is 1 and this will change to 0. So this is what happening when we try to change the values of the variables, but which is quite different from the C language. In C language, the current, I mean the previous value will get replaced with the current value, but in the Python, a new object is created and the variable, the name is pointed to the new object. That is how everything works in Python. So here, if I execute the third statement, what happens? First it will check if the object is present in the memory. 6.78, no. First it will check if the variable is, then it will check the object. First it will check a is present, then it will check 6.78. 6.78 is not present, so it will create 6.78 and then it will assign this a to here. Then this reference count will become 0, and for the 6.78 object, the reference count is going to be updated to the 1. So that's how we, you know, we try to replace, I mean we try to change the values in Python. It's a bit different from the C language. So now we are going to discuss the very important topic, which is called immutability. This is very important in memory management. So what so what is meant by immutability? Okay, the main the main concept of immutability is not changeable. So immutability means not changeable. So if I say that an object is immutable, then what I'm trying to say is that we can't change that object. So let's just like we saw here. Here, did we change the object here? Did we replace it when I try to assign a is equal to spam? Did I change the 47? No, I created a new object, so I'm not changing this object. So this object is immutable because I'm unable to change the object. So immutability means not changeable. When I can't change something, then I say that the object is nothing but the immutable. Okay, so here the concept of immutability is that once we create an object, we can't perform any changes to that object. If we are trying to perform any changes, with those changes a new object will be created. That's what happened here. First of all, we can't change this object. If we try to change this object, then a new object will be created and it will get assigned to this new object. A new object is created and it will get assigned to this is the concept of immutability. Okay, so if you're trying to perform any changes, with those changes a new object will be created. The previous object will be will be deleted from the memory by the garbage collector. So the next idea is that each object can have a lot of names. So if I create a is equal to 10 here, then if I give b is equal to a, what happens? First of all, 10, this is a, and then b is equal to a is nothing but this 10, so b will also point to this 10. If I do c is equal to b, then c will get pointed to this object. So this is the object and it has so many names, it has 3 names. So what happens inside the object here? What happens inside the pi object? So inside the pi object, we all know that there is a variable for reference count. First it will be 0. When we execute this one, it will turn to 1. When we execute this line, it will turn to 2 because b got added here. When we execute this line, it will turn to 3. Now how many names do we have here? We have 3 names, which means that the reference count is 3. So let's try to prove this using the code here. Okay, we will try to prove it. So a is equal to 10. Then let's try to create, let's try to create another variable and assign this b value. Then create c is equal to b. Now how to prove this one? Let's try to print the addresses of each and every print id of print id of a, print id of b, print id of c. So if you can see here, all the addresses are same. Why all the addresses are same? Because the object is one, the names are different. So all the variables a, b, c are pointing to the same object. That's the reason the address of the each and every object is same. So that's how I was able, I proved that an object can have different names here. Okay. So let's look at another example here. A is equal to 10. And then what if I want to create a new variable b with the same value 10? What happens now? Here I'm just trying to reference it. Even here I'm trying to do the same thing. I'm trying to point this b to the 10, but let's use a different approach here. First I created the 10 object, object 10, and then I want to create the same object again, and I want to create a new variable b, and I want to assign this b to the object 10. So I want to create the same object again. So what happens now? So let's remember the 2 points that I said a few minutes ago. Whenever we create a variable, first the Python will do two things. First it will check if the variable exists in the memory, and then it will check if the object exists in the memory. If the variable exists in the memory, it won't create a new variable. It will use the same variable and it will just point that to the different object. Now when the object is also exists in the memory, it won't create the new object here. Here, first I already created the 10 object. So when I'm trying to create the same object again, it won't create a new object. It will first check inside the memory. Inside the memory, we already have this A object here. So it won't create it. What it does is that it will directly point this B to this 10, just like it did here. So we will try to print the ID, then you will understand it. Print ID of B. So the addresses are same. So what happens here is that the b is directly pointing to the 10. I'll show using a diagram here. Then okay, so a, this is 10. First when I do this, when I do execute this one, see, so when I print the addresses, all the addresses will be same. So if an object is already available, it will use the existing object. That's the point. That's the main idea of the concept of immutability. So the object, first of all, the object will not change, and the next thing is that if the object already exists inside the memory, then there is no point in creating a new memory. So what are the advantages of this approach? Okay, these are the advantages. First of all, the memory utilization. Let's take an example here. First of all, if we are trying to register ourselves in the to get an voter ID, so we need to, whenever we try to apply for an voter ID, then we need to give our name, and we need to give all our details here. We need to give our age, we need to give all the other details, and we also need to give the location here. Okay, so for name, I mean, if there are like 1 lakh voters who are being registered, so for 1 lakh voters, the name will be obviously different. I mean, some names will be same, but most of the names will be different. So there is no issue. For age also, most of the time, I mean, there will be so many people with the same age as well. But if you have 1 lakh, then obviously there will be some, if we have like 5,000 will be of one age, 1,000 people will be of a particular age. So and the location will also be differ, okay, based on the place that you live in. The location also differs. So for example, here in this 1 lakh voters, 20,000 voters are from Hyderabad. Okay, so the 20,000 voters are from the Hyderabad. So we are going to create, obviously, when we are trying to create, I mean, 1 lakh voters, then for each and every voter, we need to create an object inside the memory. So inside the object, we need to create the location object too. I mean, as I said you, for this type of scenario, we can use the concept of list or any other dictionaries, or we will discuss this later. But for basic understanding, we are going to just define, like, put all these objects here: name, age, location, etc. Okay, like this we are going to create. And this location object is going to, I mean, the location is going to point to the Hyderabad object. Okay, so for example, if we have 20,000 voters who live in Hyderabad, then is it a good practice to create 20,000 objects with the object? I mean, is it a good idea to create 20,000 objects with the name Hyderabad? Like, because everyone is living in the same place, but is it a good idea to create 20,000 objects? Okay, there is no point, right? I mean, the memory will get wasted. So instead of that, if what we can do is that, like, using the immutability concept, that's how the Python is built. We only create one object here, and all these 20,000 voters will pointing to the same object. Then we are only creating one object here, but 20,000 people are going to point to the same object. So that's how we are going to save the memory here. Okay, so the performance will also get increased. Why the performance will get increased? If we, whenever we create an object, there is a lot of stuff going on in the memory. So it's not really easy for the operating system, I mean, for the hardware, to create an object every time. So instead of creating 2,000 objects, we are just creating one object. So obviously the performance will be increased, because we are spending less time on creating the objects. Okay, so these are the advantages of this immutability concept. Okay, so now we already talked about this concept, the reference count concept. We will talk about this again, just for the garbage collection concept that we are going to discuss in a bit. So here, first x is equal to 300. This got created here, and what happens, x will point to this object, then y is equal to 300, y will point to this object, and then this is the list object. Okay, I already told you, when I use square brackets like this, then it is nothing but a list object. Okay, so what happens here, z, inside the z, and this will point to these objects. So the object is 1, but the reference values are 4, 1, 2. This is, this is not 3. Okay, because in the list is just like an array. We have 0, z0 and z1. So we have 4 reference variables here. So that's the reason the reference count is 4 here. So whenever we assign a variable, then the reference count will be increased. So we just now saw how to increase the reference count. So how we can increase the reference count? By just creating, new reference variables for the same object. If we have x is equal to 400, then if I use like this, then 400 x will point to this, and now y is going to point to this. That's how we increase the reference count. Now we'll see how we can decrease the reference count. So here we already created two, I mean, two variables here. First, 300 is an object, and x is a reference count, I mean reference variable. Y is also the reference variable here. So here we have, what is the reference count for this one? Type is int, value is 300, and reference count is 2. We have 2, so this is 1, this is 2. So how can we decrease the reference count? So here now we have two reference count here. X is equal to true, y is equal to none. What we are doing here, we are trying to change the object here. I mean, just like we did in the previous, we are trying to replace the 300 with true, but it's not going to get replaced. What happens here? A true object is created, and this x is going to point this true, and the reference count will become 1 now, because we have only y here. This y, the 2 will be decremented to 1. So when I change this y to none, which means that this y will point nothing. Okay, this y will point nothing. None is the data type, where if we want a variable to point to nothing, then we use none. So now this y is pointing to nothing, so now this 300, the reference count will become 0 here. Now what happens whenever an object reference count becomes 0, the garbage collector comes to the picture. So when the garbage collector is going to the garbage collector is going to destroy the object. Okay, so here the for the 300 object, the reference count becomes 0, because we tried to change the references. We pointed the x to the true, and we pointed y to nothing. So the 300's reference count becomes 0. So the garbage collector will come and it will destroy this object, because it's no longer used, right? Because no one is pointing to the 300, then we have no use with that object. So we will, I mean, destroy the object. Okay, so this is one way of decreasing the reference count. We have another ways. We have something called del keyword. So the del keyword is used here. We have 300, and the y is also pointing to this one. So now del x, when I execute this one, del x, then the reference will be deleted. If I x del y, then this reference will be deleted. So it doesn't delete the objects, it removes the names as the references to that object. So when I say del x, I mean, first we have like this, it will not delete the object 300, it will delete the reference variable like this. Okay, and when if y is pointing to this, if I use the del keyword for a y like this, then it will remove the reference count. Sorry, it will remove the reference, and the reference count will be decremented here. And we can also decrease the reference count when we come out of the scope. Let's try to understand this. Def, let's take any function like this, print hello. So def is used to create a functions. We will discuss about this keyword when we discuss the concept of functions here. So def print hello, what I'm going to do here is that I'm going to create a variable inside the function. Okay, inside the function I'm going to create a variable movie is equal to captain, and I'm printing the movie here. So after coming out of the function, I'm going to call the function. So first we're going to create a function, then we should call the function. so that the statements inside the function get executed. Okay, unless we call the function, these statements won't get executed. Okay, first we need to call the function. So first we are going to call the function, print hello here. We're going to call the function here. So when we call the function, this variable will get created, movie will get created, and the object captain will get created. And for this captain object, mm, okay, for this captain object, the reference count is 1. So then it will print it. Then after coming out of this function, this will become 0 because this variable is local variable. We will talk about these scopes when we talk about different types of variables, and we will talk in our upcoming lectures. But just try to understand that inside the function, this is called the local namespace. So whatever variables we create inside the function, after completing the function, it will be deleted because the function will be stored in a stack. We will talk about it in the upcoming lectures. This is not the right time, but just understand that when we come out of this function, the reference count will become 0 because we are no longer using this function. Okay, we are no longer using this function. We already executed the function. uh, when I create a function like this inside a stack, inside the function stack, the function, the values will get created here. And after here the movie, all this stuff will be created. Whatever is available inside the function will get created. After completion of this will get deleted. So once it gets deleted, the reference count becomes 0. So these are the three ways to decrease the reference count. We can change the value, we can try to change the value, then we can use the del keyword, and then we can decrease the reference count. How? By, if we declare a variable inside the scope, the reference count will be incremented once we come out of the function. Okay, so as I already told you, once there are no more references, the object can safely removed from the memory. So when the reference count becomes 0, when the reference count becomes 0, the object will be safely removed from the memory. So that's all about the immutability concept. The basic idea of immutability is not changeable, which means that when an object is created, we can't change it. Okay, if we are trying to change it, then a new object is created. That's the concept of immutability. Now we'll discuss the concept of mutability here. So just like immutability means not changeable, mutability means changeable, which means that we can change the content of the object. We can change the content inside the object. So here a is equal to 10, which is immutable object, and this L is equal to 10, 20, 30, 40. I already told you that list can store multiple objects or values. Okay, usually we call this as an objects. So when I create like this, 10 is an object, 20 is an object, and next we created 30, and then 40. Okay, we have four. For object 10 we have one reference. For object okay, for object 30 we have one reference. For object 40 we have one reference. So what if I want to change this value? Okay, I want to change the 10 here. So what I can do is that I can use the concept of indexing, just like we discussed in the strings. The same applies in the list. Just like the indexing concept, we can use it here. I can use L of 0 is equal to, let's assume I can take 777. So what happens now is that a new object is not created here. It will directly replace this 10, and the 777 object is created here. So it will directly replace the value here. So that's the idea of mutability. It won't create a new object, it will directly replace the new value in that place. Okay, in this place, in the 10 place, first it used to be 10, right? It will delete the 10 and the 777 will get stored here. So now we will talk about the garbage collection, which is very important to understand how the objects are created, how the objects are destroyed inside the memory here. So we can also do we can do garbage collection in two ways. We can do it manually, or it will done automatically by the Python. Usually people, the automatically the garbage collector comes to the picture and it will delete the objects. So we will see how it happens. So a way for a program to automatically release the memory when the object taking up that space is which is no longer in use. When the object is no longer in use, when it is no longer in use, then this object will get deleted from the memory. Okay, so there are two types of garbage collection. There are two types of garbage collections. The first one is reference countings and next one is tracing. So first we'll see how the garbage collection works for the reference counting. So what happens is that we all know that whenever we create an object and when we try to point any variables to an object, the reference count will be incremented here. We have something like this, a b c, then we have 3. So when we delete these references, then the reference count becomes 0 and the object will get deleted. So whenever the reference count becomes 0, the object gets deleted. Okay, that's how the garbage collector works for reference counting. So this is the algorithm here. We will just add and remove the references in the code. I mean, whenever we create a variable, the reference is added. How we can remove, we already saw a few minutes ago. How we can decrease the reference count, we can decrease it by using del keyword. Whenever we get out of the scope from the function, the reference count will be decremented. So we can, this is the first point. I mean, we can add and remove the references based on a code, and when the references reaches 0, we can remove that object. Just like we discussed before, when the reference count reaches 0, we can remove that object. And there is also something called cascading effect, which means that for example, I have an object 10 here and it is pointed by a, and this object is pointed to 20. So when this gets deleted here, I mean, when this reference gets deleted, this will also get deleted. That's called the cascading effect. We will decrease the reference count of any object that the deleted object was pointing to. So here, this is the deleted object. We are deleting this object here. We'll also decrease the reference count. For example, if this 20 has reference count 1, then will decrease it to 0. Then it will get deleted. But if the reference count is 2, then we will decrease it to 1. It won't get defeated. I mean, it won't get deleted. It will only get deleted when the reference count reaches 0. But we will try to decrease the reference count. Okay, even here, a b c, just because I removed a, it won't get deleted. When the reference count becomes 0, then only the object gets deleted. So even here we are just decreasing the reference count. It doesn't mean that the object will get deleted too, but if the reference count is only 1, then it becomes 0, then the object will get deleted. It depends on how many object I mean, if you have something like this, it depends on how many references that this 20 have. If this 20 have more, then even though we decrease here, it won't make any effect. But it only has one, it only has this one. Then when we delete this will also get deleted, and both of these objects will get deleted from the memory because these objects are of no use. So this is called the cascading effect here. So the advantages of this reference counting garbage collection is that it is easy to implement. When the reference count is 0, objects are deleted immediately. So we have some disadvantages too. The space overhead is nothing but for every object we are going to keep track of the reference count for each and every objects. Obviously we need more and more space, right? execution overhead. I mean, whenever we create like this, b is equal to 10, c is equal to 10, bc, the reference count is changed on every assignment. Every assignment I'm going to increment this. First it will be 1, then it will be 2, then it will be 3, then it will be 4. So we're just going to, I mean, increase our work here. So but the main disadvantage of reference counting is that it doesn't detect any cyclic reference. This is very important. Let's try to understand this one. Cyclic references. So what is meant by a cyclic reference? For example, if I have a node like this, let's try to create, I mean, like whenever I create a class, first we will define a constructor here. We haven't discussed about the constructor, which is the reason I'm just writing it. Just try to understand it. Inside the node, I mean, and inside the node, I can put right variable, left variable, and maybe we can put center. Yeah. So whenever I create this node inside the memory, right, left, let's forget this center. Okay, let's just take only two variables. Look, we haven't discussed anything about classes and the constructors. So I mean, the constructor, we haven't discussed anything about the constructor here. So just try to understand that we are creating an object called node. These are user defined objects. Okay, a is equal to 10. 10 is a predefined object. Okay, integer object is already defined in Python, but classes are used to define our own objects. We will discuss that in the object oriented programming. This is nothing but the constructor. This is not the right time to discuss it, but we created a node here. Inside this we have right variable and left variable. So I'm going to point this node to something called root. I mean, we just need to create like this. We need to give values to this. This is nothing but the constructor, like object creation. We will talk it in the object oriented programming, but the only thing we need to understand here is that I'm going to assign root to this object. So what I'm going to do next, root dot right, I'm going to create another object here. Please try to understand this carefully. Now this right is being pointed to another object called, let's name it as left. Okay, so this is being pointed to left, and now sorry, we already pointed it to right. I'm sorry. Root dot right is equal to node, and left we creating another object here. Okay, now what we are going to do here is that we are again pointing the right object to left and this object to this. Okay, so what happens now? So whenever I do delete root, we know that we can use del keyword to decrease the reference count. I mean, to delete the object here. So whenever I use delete, this will get deleted. I mean, this reference will get deleted. Now the reference count of this node is just it's just 0 now. Then this whole object will be deleted. If this whole object is deleted, okay, 1 second. I didn't. Mm, I didn't mention the reference count for this first. Okay, let's try to do it again. Here we have right. Here we have left. Right is pointing to this. Left is pointing to the list. So first of all, what is the reference count of root? Sorry, what is the reference count of this node object? Reference count of this node object of node is how many references that does it only has one. what is the reference count of the no, I mean the object pointed to the right? It is 2. What is the reference count for this? Why is it 2? Because for this object the right is also pointing, this is 1, and this is also being pointed, this is 2. So which is the reason the reference count is 2. And the same goes with the left. What is the reference count for this one? The left is also being pointed, and this is also, this is 1 and this is 2. So the reason this is 2. So when I execute this del keyword, now first of all this will get deleted. Now the reference count of this node object is 0 because nothing is being pointed. Obviously now what happens, this gets deleted, the whole thing gets deleted. When this gets deleted, we just now saw that the cascading effect, when this gets deleted, when the reference count of node becomes 0, it will also decrease the reference count of the objects that deleted object is pointed to. The deleted object was being pointed to this, right, is pointing to this, so this will also get deleted. Sorry, I mean the reference count will be decremented. So the reference count of right will be decremented to 1, the reference count of left is decremented to 1. First it was 2, now it is only 1. Now tell me, how can we try to garbage collect these particular objects? Because we know that when we were using reference counts, what happens when the reference count is 0, objects are deleted immediately. Now for this route, the node object, for that the reference count of node, when it becomes 0, it got deleted. But how can the reference count of right and left will get deleted? Because these objects are pointing to each other. It doesn't have anything pointing to, like, the one that was pointing to this was already got deleted. Now how can we delete this? Because nothing is being pointed to here. The object is pointing to this one, this object is pointing to this one. We only had 3 ways to decrease the difference count. What are those 3 ways? First one is decrease the reference count. How we can do that? By changing the values for these variables. Here we don't even have the variables here. We don't even have anything to point here. Here we don't even have anything. We don't have this left or right to point to this. These objects just exist in the memory like this. We don't have anything to point, so we can't even change the value. What was the second thing that we try to understand? The del keyword. But even to use the del keyword, we need to have something to point, right? But we had nothing here. We have nothing to point. So how can we use the del keyword? We can't use. And the third one was out of getting scope. So we have nothing pointing to these objects. And how can we even? So in this scenario, the reference counting garbage collection concept will not work for the cyclic reference concept, because nothing is being pointed to here. When nothing is being pointed, the reference count will never become 0, and we can't use del keyword, and it couldn't go out of the scope. Then this will be the wastage of memory. Right now we only have 2 objects like this. What if we have 1000? What if we have 2000? So how to try to approach these type of problems? Then now we use the concept of tracing here. Okay, reference counting alone will not garbage collect object with cyclic references. So for the ones who have cyclic references, the reference counting doesn't work. We saw an example here. uh, if nothing is being pointed to these objects, there is no way that we can delete this. There is no way the reference count will go to 0, because there is no reference at all. So how can the reference count even go to 0 here? So the reference count alone will not garbage collect object with cyclic references. So here we are going to use the concept of tracing. What this tracing do, it follows an algorithm called mark and sweep. So inside the memory we have something called garbage collector object. It is the root object here, the garbage collector object. For this object, all the heap objects will get attached like this. Okay, and this will attach like this will attach it like this. I mean, each and every object that we create in Python will be attached to this root garbage collector object. So this garbage collector object, the Python virtual machine knows where this garbage collector object is there. So what it will do is that first it will start from here. I mean, uh, let's not forget that we also have some cyclic references here which are not connected because it doesn't have any reference here. They just exist in the object. So what happens now? This what this tracing do is that first it will start from here. Okay, it will go to this. It will go to this, and it will check if the reference count is 0 or not for this particular object. If the reference count is 0, it will delete it. If the reference count is not 0, it will go to the another object, it will go to another object, it will go to another object, it will go to another, it will go to another. So the reference count, it will check for each and every reference count, and the object which are not traced will be not covered by this I mean, will not be marked, and they'll get deleted in the algorithm. Okay, so Python uses something called the tracing, which is nothing but the generational garbage collection. It is the generation garbage collection here. I mean, the mark and sweep algorithm that we just saw, we are going to use, we are like it's combination of mark and sweep, and the some other concepts in Python that we will see in a bit. So what Python does is that Python maintains a list for every object created as the program is run. So whenever we create an object like this, b is equal to 20, c is equal to 30, what it will do is that it will create three lists. First one is generation 0, generation 1, generation 2. So whenever we create an object, the objects will be stored in this generation 0 list. So 10, 20, 30, like so on. Okay, like until based on the memory and based on the size of the list, all the objects will be stored in the generation. And so what happens here is that there will be a threshold value for this. For example, if we have the threshold value as 100, so whenever this generation 0 reach 100 objects, then the algorithm, I mean the generation garbage collection algorithm will be run on this generation. So what it will do, so only the container object with reference greater than 0 will be stored when the number of objects in the generation reaches a threshold. Python runs the garbage collection algorithm on that generation, and any younger generation, younger than it. For example, here generation 0 is younger. This is older than generation 1, older than 0, older than 0, and 1. So when the number of objects in the generation reaches a threshold, if we put that threshold as 100, when the generation 0 becomes, or any generation, if it reaches a threshold 100 objects, then this algorithm gets run. So what is the algorithm here? So first of all, it will create a list here. I mean, we already have three lists which are generation 1, sorry, generation 0, generation 1, and generation 2. So once let's assume that in the generation 0 it reached the threshold, which means that the 100 objects, for if the threshold is 100, that the 100 objects are already created. So first the Python will make a list for the object to discard. Okay, it will make an empty list here. It will make an empty list, and it runs an algorithm to detect the reference cycles. The first, just like I discussed here, the mark and sweep, it will start from the beginning and it will run through each and every object. So in the same way, even in the generation 0, the this algorithm, what it does is that it will start from here. It will start from each and every object, and it will run the algorithm for each and every object. So it will try to it will try to detect the reference cycles. If an object has no outside references, it's put on the discard list. So what happens here, just like we discussed here, it will and try to go to each and every object here. This is the mark and sweep. So in Python, we tried to include this mark and sweep algorithm, and we created three lists for that. So for the first list, if the first list got 100, what it will do, it will do this algorithm. Each and every object will be present in these generations. When we have the cyclic references, this algorithm will check if the object has no outside references, just like we saw here. It doesn't have any outside references. Okay, these two objects, it doesn't have any outside references. So here, if you can see here, it doesn't have any outside, nothing is being pointed to these objects. So in this generation 0 list, the algorithm, what it will do is that it will go from like it will traverse through each and every object. First object, it will go to this first object, and it will check if the object has cyclic references. I mean, how does it check if it has cyclic references? It will check if the object has any outside references or not. If it doesn't have any outside references, it will delete this object from here. If it doesn't have any outside references, okay, it will delete this object and it will add here. And it will check for this one too if it doesn't have any outside references, and it will add here. But all the objects which have the references will stay in that generation list. And when the cycle is done, I mean, it will traverse to each and every object here, all the 100 objects. And if when the cycle is done, it frees up the objects on the discard list. What it will do, it will delete these objects. So that's how the garbage collection is done for the cyclic references. So, and like here we try to discard the objects which doesn't have any outside references, and we put these objects in the discard list. But we still have some objects here, right? There are some objects which survived, I mean, which has survived this algorithm. These will get transferred into generation 1. Now this will become empty here, and we have objects here. Now whenever we create a new objects again, now this will get filled again here. This will get filled again, and the algorithm will get run again, and whoever survives this algorithm, it will come to this algorithm, I mean, sorry, this generation, and the same cycle keeps on going. So what happens when the threshold value, like when generation 1 meets its threshold? For example, if the generation 1 have a threshold of 200 objects, so when the 200 objects gets reached for the generation 1, the same algorithm gets run to this generation and also its younger generations. That's what we made a point here. When the number of objects in a generation, in any generation, reaches a threshold, Python runs a garbage collection algorithm on that generation and any younger generation younger than it. So if when the Python is running an algorithm for generation 0, it doesn't have any younger generation. So only for this generation the algorithm will be run. But for the generation 1, it has another younger generation called generation 0. So the algorithm will be ran like for this generation and also for the generation 0. So whoever survives this particular generation, it will get transferred to generation 2. Okay, now all these objects will be deleted, and this generation 2 will get, I mean, all these objects who get survived in the generation 1, they will be transported to generation 2. All the objects survived in the generation 0, they will get transported to generation 1. But what if generation 2 objects gets, what if what about the objects that survives generation 2? They will not be transported to anywhere. Whoever survives the generation 2, they will stay in that list only. Okay, so So we discussed two concepts here in garbage collection. The first one is reference counting, and the second one is tracing. So the first one, what it will do when the reference count reaches 0, it will immediately clean up the objects when the reference count becomes 0. But if we have a cyclic reference, then we need to wait for the garbage collection algorithm, the generational garbage collection algorithm to be, I mean, we need to wait for the algorithm to run. Okay. Generational garbage collection algorithm. So when an object is created, the reference count will be incremented when we have new references. When the reference count becomes 0, then it will automatically get cleaned up. But if we have a cycle, what is meant by a cycle? We already discussed here. When we doesn't have any outside reference, here we don't have any outside reference, then it's impossible to make the reference count to 0. So that's when the generation um, garbage collection algorithms gets implemented here. So objects with cyclic references get cleaned up by generational garbage collection algorithm. So this is all about the memory management, the basics of memory management. I think we already we almost covered 70 to 80% of the concept in the memory management. This is just a theory part. We will talk more about the memory management concepts, like we will understand how I mean how the Python people they implemented this code in the C language, because we are using the C Python version. We will also talk about how the Py object, all the parent classes of this Py object, all the child classes, all the methods in the Py object, and the methods inside the methods in the garbage collector module. We'll talk about these concepts in the upcoming lectures. As of now, this is just the basics. So I hope you understood the lecture and all the concepts related to the memory management in Python, how everything works behind the Python. So that's all about today. Thank you so much. I'll see you in the next lecture.